Alright, this is part 2 of section 2.2. Now we're looking at solving rational equations. Okay, so a rational equation contains at least one rational expression, and a rational expression is really just a fraction of two polynomials. Okay, so a rational equation contains at least one rational expression where the variable appears in at least one of the denominators. So here's a few examples of rational expressions. So the goal for this is to get all the numbers in the numerator. So you want to eliminate all the denominators, and the way to do that is by multiplying each term by the least common denominator, or the LCD. Okay, so what we're going to do is we're going to factor all the denominators in the equation, if we can. Find and exclude values that set each denominator equal to 0. This will be important here in a minute. Find the LCD. Multiply every single term by the LCD. If, this is a checkpoint right here, if the LCD is correct, all your denominators will be gone. And once you have all your denominators gone, you don't have a rational equation anymore, and you can just solve your remaining equation. And then always make sure you go back and check your solutions in the original equation before you started changing things. So like this right here. Number one, factor everything. It doesn't look like we can factor anything here, so we're going to skip that step. So we're going to go straight to finding the LCD. So basically, you want to get each of these numbers right here to the same number and the smallest number you can think of. So if I look at 3x and 4, I know I can get both of those to 12. And then if I look at 12 and 6, well, I can get 6 to 12 as well. So the LCD would be 12x. Now, that's the least common denominator. If you are struggling with finding the least common denominator, one of the easiest way to do is this. If you just find the common denominator, if you multiply all the numbers together, and then you tag on an x, you can multiply that number by each and every term. It will come out the same. It just, you will have bigger numbers. Okay, so we're going to take 2 over 3x and multiply this by 12x. And actually, I'm going to put this over 1. 12x over 1 is equal to 12x over 1 times 1/4 minus 12x over 1 times 1 over 6x. And this is where we need to start canceling. So I've got an x here and an x here that can cancel. Can also cancel out this 3. I'm left with a 4 right here. Can cancel out this 4, and I'm left with a 3 here. Cancel out this x and this 6, and I'm left with a 2 right here. So then, okay, so we're going to take that 4, multiply it times that 2, equal to 3. Don't forget this x right here. That'd be easy to forget. Times a 1 minus 2 times 1. So this will be 8. This will be 3x minus 2. Now look, what we did was we went from here, and now we are at this equation. So it made it a lot more simple to work with. So I'm going to add 2 to both sides. So that's going to be 10. This will be 3x. Divide both sides by 3. I'm going to come over here. So x is equal to 10 over 3. Now before I say, okay, that's my final answer, I need to check the 10 over 3 into my original equation. Okay, so I'll have 2 over 3 times 10 over 3 is equal to 1/4 minus 1 over 6 times 10 over 3. Okay, now these 3's will cancel out, and this 3 will cancel out, leaving a 2. So I have 2 over 10 is equal to 1/4 minus, okay, that would be 1 over 20. Okay, now I can get each of these to 20. So my LCD is 20. So I will multiply each one of these by 20. Okay, cancel out the 10, left with a 2. Cancel out a 4, left with a 5. Cancel out the 20s. So now I have 2 times 2 is equal to 5 times 1 minus 1. So 4 is equal to 5 minus 1, and 4 is equal to 4. So since that came out to a true statement, that means that x equals 10 over 3 is my answer. Now let's look at this one with a more complicated denominator. Now notice this one has an x minus 2, this one's an x minus 1, and this one's a combination of these two right here. The LCD is easier for these, it's just the combination of the two. So x minus 1 and x minus 2. So I'm going to take this equation, I'm going to do x minus 1 times x minus 2 over 1 times 3 over x minus 2 is equal to x minus 1, x minus 2 over 1 times 1 over x minus 1 plus x minus 1, x minus 2 all over 1 times 7 over x minus 1 times x minus 2. Then I'll go out and cancel x minus 2's, x minus 1 here, and both of them here. So then I'm left with x minus 1 times 3 is equal to x minus 2 times 1 plus 7. So I'm going to distribute this 3 to the x and to the 1. So 3x minus 3 is equal to x minus 2 times 1 is just itself, plus 7. So now we've taken this equation and transformed it into this one right here without denominators. Okay, so then I'm going to clean up this side right here. So this is going to be 3x minus 3 is equal to x plus 5. I'm going to subtract x from both sides. So come over here. I will get 2x minus 3 is equal to 5. Add 3 to both sides. 2x equals 8. Divide by 2. X equals 4. Again, before we say, okay, x equals 4 is my final answer, we have to check it in the original equation. Okay, so this is going to be 3 over 4 minus 2 is equal to 1 over 4 minus 1 plus 7 over 4 minus 1, 4 minus 2. So this will be 3 over 2 equal to 1 over 3 plus 7 over, well, that will be 2 times, whoops, that will be 3 times 2. So this will be over 6. The LCD is 6. So I'm going to multiply each term by 6. And this will cancel out, left with a 3. Cancel out, left with a 2. And those just cancel out completely. So I have 3 times 3 is equal to 2 times 1 plus 7. So 6 is equal to, 9 is equal to 2 plus 7. Come over here. 9 is equal to 9. So that means that x equals 4 is our final answer for that. Okay, now let's take a look at this one. Notice I've got an x plus 1, x minus 3, and then I've got x squared minus 2x minus 3. So this is where I need to factor the x squared minus 2x minus 3. So we have 5 over x plus 1 over 1 x minus 3 is equal to negative 6 over, and then we're going to factor that. So an x here and x here. I can factor that 3 into a 3 and a 1. So that's a negative 2, so my 3 needs to be negative and my 1 needs to be positive. Because when I multiply these two together, I get negative 3. But when I add them, I get negative 2. Which, if you struggle with factoring, sneaky suspicion that it's the combination of those two, which it is. Okay. So my LCD is the combo of those two. Okay, so I'm going to take x plus 1, x minus 3 over 1 times 5 over x plus 1 plus x plus 1, x minus 3 over 1 times 1 over x minus 3 is equal to x plus 1, x plus 3, or minus 3, over 1 times negative 6 over x plus 1, x minus 3. And then we'll start canceling out. Cancel out the x plus 1, x minus 3, and then both over here. So I'm left with x plus 3, or minus, times 5, plus x plus 1 times the 1, so I'll just leave it like that, times negative 6. So then distribute this 5 to the x and to the 3. So 5x minus 15 plus x plus 1 equals negative 6. Combine these two x values. That gives you 6x. Combine these two constant values. That gives you negative 14 is equal to negative 6. Going to add 14 to both sides. Come over here. So that'll be 6x is equal to 8 divided by 6. And then I can take 2 out of both of those. So I'll be left with 4 over 3. And then again, I need to check this back in my original equation. So we have 5 over 4 over 3 plus 1 over 4 over 3 minus 3 is equal to negative 6 over 4 over 3 squared minus 2 times 4 over 3 minus 3. Okay, I'm going to do a little side work over here. The 4 over 3 plus 1. I'm going to change the 1 to a 3 over 3 because any number over the same number, that's a form of 1. I just need the denominators the same. That'll give me 7 over 3. So 5 over 7 over 3 plus, and then 4 over 3 minus 3 over 1. I'm going to multiply that 3 over 3, so the denominators are the same. 9 over 3, so 4 minus 9 over 3. That's going to give me a negative 5 over 3. So 1 over negative 5 over 3 is equal to negative 6 over, that's going to be 16 over 9. And then minus 2 times 4, 8 over 3 minus 3. Okay, so that's going to be 16 over 9 minus 8 over 3 times 3 over 3 minus 3 over 1 times 9 over 9. Just trying to get all the denominators the same. 16 over 9 minus 24 over 9 minus 27 over 9. So I've got 16 minus 24 minus 27 all over 9. That gives me a negative 35 over 9. So that gives me 5 over 7 over 3. I'm going to take this minus to the front. So minus 1 over 5 over 3 is equal to negative 6 over negative 35 over 9. So we have a fraction in the denominator. We can flip that, and I will do that in the second part.